Right, hello girls, welcome to Upper 5 AP Corona Maths. Right, the section starting with now, we're having a break from stats and we're going to be working with, I'm going to be heartbroken, partial fractions, which is part of paper 1. Okay, and first bit's pretty easy. Okay, I want you to just go try simplify those two. Okay, 2 over x plus 1 plus 3 over x minus 2. Right, well you've been doing this since grade 1. Okay, so to add fractions, you get a common denominator, which is x plus 1, x minus 2. What do we times the bottom by there? We times the denominator by x minus 2, so let's times the top by x minus 2, plus there times the bottom by x plus 1, so let's times the top by x plus 1. Okay, and if we simplify that, the numerator becomes 2x minus 4 plus 3x plus 3. We're going to times out the denominator, we don't normally, but we're going to do it this time. X squared minus 2x plus x is minus x minus 2. And I end up with 5x minus 1 over x squared minus x minus 2. Right. Nothing new there. Okay, just simplifying. Okay, you're adding two fractions together. So this process from here to here is called simplifying. But now we're going to show you when you're resolving into partial fractions, what you're saying is the sum of what fractions, okay, two fractions will give you this. Okay, what two things added together could give me that. Okay, and that's what this section is about, resolving into partial fractions. What fractions added together can take me back to that. So, let's take this one over here. We just did. And we're going to start with that now. And we're going to, the question would say, express in terms of its partial fractions, or it would say resolve into partial fractions, something like that. Okay. And we've got 5x minus 1 over x squared minus x minus 2. So what we should end up with as an answer, when I've resolved into partial fractions, is 2 over x plus 1 plus 3 over x minus 2. Right. Can you see this over here on the board? Okay. So, if I take this over here, 5x minus 1 over x squared minus x minus 2. So your first step, okay, is going to be to factorize your denominator. If you can. Okay, so step 1, factorize your denominator. So in other words, this is going to become 5x minus 1 over x minus 2x plus 1. Always check it. You don't want to make a mistake here. You'll get x squared plus x minus 2x is minus x minus 2. So always take your time and check that's correct. Right. Now, the next thing we're going to do is write it as a sum. So this thing we say, well, it could be written as something, we don't know what that is yet, over x minus 2 plus something else over x plus 1. So express as a sum is your next step. Okay? The next thing we want to do, so now the objective becomes solve for a and b. Okay? A of x minus 2 plus b of x plus 1. So now, in order to do that, we're going to get rid of the denominator. Well, there's no real math process called get rid of, but what we're really doing is timesing both sides of this equation by the LCD. And the LCD is x minus 2x plus 1. So when I times this thing over here by x minus 2x plus 1, I'm left with 5x minus 1. When I times this by x minus 2x plus 1, the x minus 2's cancel, so I'm left with a times x plus 1, and that I'll be left with b times x minus 2. I'm timesing everything by x minus 2x plus 1, every single one of those three terms. Right, don't times it out, just leave it like that. Okay, so now I'm trying to find a and b. Well, the easiest way to start off with is to say, okay, what number can I sub in here so that I get rid of, what value of x can I sub into here so that I get rid of a? In other words, I get rid of this whole term. Well, if x is negative 1, a will disappear, we'll replace every x with -1, and the only variable I'll be left with is b. So this is always the first thing I try to do. So I'll say, right, let x be equal to -1. So if I replace x with -1, on the left-hand side I'm going to have 5 times -1 minus 1. And over here, if I replace x with -1, -1 plus 1 is 0, that whole thing is gone. And over here I've got b, and I replace x with -1, minus 2. So I get -5 minus 1, which is -6, is equal to -3b. Okay, and I divide both sides by -3, and I get 2 is equal to b. Okay, so I get b is equal to 2, which is looking good because I've got 2 over x plus 1, which is what I wanted over there. Okay, so now I want to sub in, so I get rid of that b. What number can I replace x with so that that whole term disappears? Well, if x is equal to 2, that whole term disappears. So I'll choose x is equal to 2. And then the left-hand side becomes 5, replace x with 2. Okay, I've got to replace x with 2 over here. So I'm going to get a times 2 plus 1. When I replace x with 2, that whole thing disappears. So I'm left with 10 minus 1, which is 9, is equal to 3a. So divide by 3, I get a is equal to 3. So I've got b is 2 and a is 3. Always write your final answer down. Okay. Okay, so in other words, what we've shown is that 5x minus 1 over x squared minus x minus 2 is equal to, well, a we know is 3, so it'll be 3 over x minus 2, plus b we know is 2, so plus 2 over x plus 1. And what do you know? We said that if we add it together, I get that. And I've worked backwards. I've got 2 over x plus 1 is equal to 3 over x minus 2. So resolving this process of here to here is called resolving into partial fractions. You're saying what fractions added together take me back to that. Okay, so your steps were factorize the denominator, express it as a sum, okay, get rid of the denominator, solve for what we call capital A, B, sometimes there's a C as well, okay, and you do that initially by subbing in an appropriate x value to get rid of a term. So we subbed in -1 to get rid of the A, and we subbed in 2, okay, to get rid of the B, okay, and that helped us to solve. And don't forget to write out your final answer. Okay, write out that final last step, okay, otherwise you'll get penalized for that. Right, so there, ladies and germs, is your first partial fraction sum. Hello. Alright, welcome back. So in the interval I successfully managed to spill on my shirt. I'm an idiot. Right, anyway. Okay, so there are 4 types of partial fractions that we're going to resolve. Okay, type 1, well that's like the one we just did. Okay, and you recognize it by the fact that degree, in other words the biggest exponent but the degree of the numerator is less than the degree of the denominator, and the denominator can be factorized into linear factors. So we're going to do another one of these type 1s. So the question, the way they'll ask the question is resolve into partial fractions. What does that mean? It means what fractions can be added together to give me this thing over here. Okay. The reason why this is important is when we eventually do something called integration, it makes our life a lot easier. So, first of all, is it a type 1? Yes, because the degree of this expression is of the numerator is 1, and the degree of the denominator is 2, so that's less than that. So that's the first thing we look for, and that can be factorized. So 3x plus 5 over x squared plus 3x plus 2 can be written as 3x plus 5. Be careful with your factorizing. And we have x plus 2x plus 1 times back out in your head. You get x squared plus 3x plus 2. So we want to write that as a sum. So it can be written as a over x plus 2 plus b over x plus 1. Right, the next step, if you remember the steps, was to get rid of the denominator from this whole expression over there. So how do I do that? I multiply both sides, every single term, by x plus 2, x plus 1. So I'm going to be left with 3x plus 5 is equal to a. Over here, I'll have x plus 1 times by x plus 2, x plus 1. I'll have plus b, x plus 2. Right. So now my objective is to solve for a and b, and the easiest way to do that is, first of all, to try to get rid of a term. So what can I sub in to get rid of the a's? Well, I can let x be equal to negative 1. So if x is equal to, I'm actually going to go over here. If x is equal to negative 1, I'm going to get 3 times negative 1, replace x with negative 1, plus 5 is equal to a times negative 1 plus 1. You have to write that step down, plus b times negative 1 plus 2. Every single x I've replaced with negative 1. When I simplify that, I'll get negative 3 plus 5, which is 2. The a, that'll disappear because that's 0. And I'll get negative 1 plus 2 is 1. So I'll get b is equal to 2. Right? I'm not done because I've still got to solve for a. So to solve for a, I've got to say, right, I need to get rid of that b. What can I sub in to get rid of that b? Well, if I let x be equal to negative 2, then that'll be 0, so b disappears. So if x is negative 2, I get 3 times negative 2 plus 5. I'm replacing every single x with a negative 2 is equal to a times negative 2 plus 1 and b times negative 2 plus 2. So I get negative 6 plus 5, which is negative 1, is equal to negative a, and that'll disappear. Okay, so in other words, a is equal to 1. Right, so don't forget to write the final answer down. So what we've shown is that 3x plus 5 over x squared plus 3x plus 2 is equal to a, which is 1. Equal to 1 over x plus 2 plus b, which we worked out to be equal to 2 plus 2 over x plus 1. And if you want, if you're really bored, go add those two together and hopefully you will. You check x plus 1 plus 2x plus 4 is 3x plus 5. Yep, you will. Okay, you'll get back to that. So that result is resolved into those partial fractions. Fantastic. Right, so we're back again. So, if we have a look, okay, I want you to go on Teams, this exercise I've uploaded. It says Evans exercise 2.1. Go print it out or use it off your screen, and I'm going to do a couple with you though, okay, but I first want you to try it yourself. So I want you to try this. Express as partial fractions 27 over 4x cubed minus 9x. Give that a go. When you've tried it, you can come back and carry on watching the video. Right. So, first of all, is it type 1? Yes, that degree is 0. Okay, the degree over here is 3. That's less than that. And can this be factorized? Well, let's have a look. So I'm going to get 27 over, well, take out x as a common factor first, and you're going to get 4x squared minus 9. Okay, are we finished factorizing rat bags? No, we're not. Okay, so we're going to get 27 over x, okay, times 2x minus 3, 2x plus 3. Kira, have you cried today yet? If not, a good cry will do you good. So I get 27 over x, 2x minus 3, 2x plus 3. Okay, so it's been resolved. Okay, it's been factorized into linear factors. It doesn't matter that they're 3, that's lovely. So we know resolving partial fractions means write it as a sum. So this could be written as a over x plus b over 2x minus 3 plus c over 2x plus 3. There are 3 things, so we're going to express it like that. Okay? Now, same as last time, I want to get rid of the denominator, so I multiply everything. I multiply all 4 terms by x, 2x minus 3, 2x plus 3. And when I do that, I'm going to get, well, the whole denominator will disappear. with A, I'm going to have 2x minus 3, 2x plus 3. With B, if I multiply it out, I'm going to have x, B times x, plus B times bx times 2x plus 3, plus C, well, I've still got that x, it's going to be cx times 2x minus 3. Okay, so we're going to be coming back to this bit over here quite a bit. Okay, this is kind of going to be, forget about the rest and we just start working with this. So, the first things, I want to sub in to get rid of things. Right, so if I sub in x is equal to 0, to agree with me, I'll get rid of that thing over there, and I'll get rid of that thing over there. Okay, so the first thing I'm going to try is to sub in x is equal to 0. So if x is equal to 0, I'll get 27 is equal to a, 2 times 0 minus 3, okay, times 2 times 0 plus 3. Bx will be b times 0, so that whole thing will disappear. Cx will be c times 0, so that whole thing will disappear. So I end up with 27 is equal to a negative 3, 2 times 0 is 0, 3. So I'll get 27 is equal to negative 9a, divide by negative 9, and I get negative 3 is equal to a. Okay, cool beans. So I've got a. Right. Now, I need to sub in something else. Okay, well, for 2x minus 3 to be equal to 0, 2x is equal to 3, so 3 over 2 is going to work. Okay, so if I put x is equal to 3 over 2, then that'll disappear. 2x minus 3 I'm looking for, and that'll disappear. Okay, so, and it'll just leave me with that term over there. So, if x is equal to, the next thing, remember I'm constantly subbing into that thing over there. So if x is equal to 3 over 2, okay, subbing down into this thing here, I'm going to get 27 is equal to, x is 3 over 2, this whole term will disappear. 2 times 3 over 2 is 3 minus 3 is 0. We'll just be left with that thing over there. So 27 is going to be equal to b. Okay, replace x with 3 over 2. And then 2 times 3 over 2. I've replaced the x, every x, with 3 over 2. 2 times 3 over 2, okay, plus 3. That whole thing will disappear when x is equal to 3 over 2. Okay, right, so I'm just going to neaten that up. Remember that means number 1. So I get 27, you can use a calculator if you want. B times 3 over 2. Here, the 2's are going to cancel, you'll be left with 6 over 1. So I get 27 is equal to 18 divided by 2 is 9b. Okay, so divide by 9, and I get b is equal to 3. Right, getting there? So I've got a and b, I've still got to find c. To find c, well, if I want 2x plus 3 to be 0, I can get rid of this term and I can get rid of this term. Okay. So what's the appropriate substitution? I'm going to get x is equal to negative 3 over 2. So if I sub in x is equal to negative 3 over 2, I'm going to get rid of that expression over there, because that will become 0, the whole thing will become 0. So I'm going to get, if x is negative 3 over 2, I'm going to get 27 is equal to, that disappears, this term over here, this term will disappear, and I'm going to be left with just this thing over here. So I'll be left with c, replace the x with negative 3 over 2, okay, times 2, replace the x with negative 3 over 2, minus 3, and I get 27 is equal to c, negative 3 over 2. Here, the 2's are going to cancel, so I'm going to get negative 3 minus 3. So I get 27 is equal to c, negative 3 over 2 times negative 6 over 1. So I get 27 is equal to 18 over 2, which is 9. So I get 27 is 9c. So c is equal to 3. Okay? And so we've got A, B, and C. So your final answer is that 27 over 4x cubed minus 9x can be resolved into, well, if I go back to here, what's A? A was negative 3, so it'll be negative 3 over x plus B over 2x minus 3, or what's B? B is equal to 3 plus 3 over 2x minus 3 plus, and then we're going to need C over 2x plus 3, so it's going to be C over 2x plus 3, which will be 3 over 2x plus 3, and there, rat bags, is your final answer for that one. Just giving you an extra second or two to pause it and copy that down and make sure that you got everything. Right, hello, rat scum. Right, so now I'm going to do number 4. So try it yourself first again. It's always better to give it a go yourself, and then you can come check your answer. So it's 11 minus x over x cubed minus 6x squared minus x plus 6. Well, let's try factorize the denominator. So we're going to have to pair up those two. Well, if I pair up those two, x squared is the common factor, and you're left with x minus 6. And remember, pairing up is only going to work if we can get another bracket which is exactly the same. So I need another bracket of x minus 6 from those two, and to get that I've got to take out a negative, or you can think of it as negative 1, same thing. Right, then I've got 11 minus x. I've got two terms here. Okay, in those two terms, what's the common factor? Good, it's x minus 6, so I get x minus 6 as a common factor. To get back to that term, I've got to times by x squared, and to get back to that term, I've got to times by negative 1. Okay, so I get x squared minus 1, and I can factorize further, and I get 11 minus x minus 6, x minus 1, x plus 1. Okay. Right, so now, so it's factorized into linear, so it's still a type 1. So I could rewrite this as a sum where I have a over x minus 6 plus b over x minus 1 plus c over x plus 1. Okay. Right. So, in order to do that, okay, we've got to get rid of the denominator. So you're going to times everything, all 4 terms, by x minus 6, x minus 1, x plus 1. And you're going to have 11 minus 6 is equal to a. Here the x minus 6 will cancel, so you're left with a x minus 1, x plus 1. Here the x minus 1 will cancel, so you're going to be left with b x minus 6, x plus 1. And here the x plus 1 is going to cancel, so I'm going to be left with c x minus 6, x minus 1. Right, now we've got to do appropriate substitutions for x in order to solve for a, b, and c. It's quite exhausting. Okay, so let's say, well, if x is equal to 1, we'll get rid of that, and we'll get rid of that. So let's choose x is equal to 1. So if x is equal to 1, I'm going to constantly substitute. This becomes my main thrust of the sum now. Okay, if x is equal to 1, I get 11 minus 1 if I replace x with 1. X is equal to 1. That'll disappear. This won't disappear. So I'll get b, x is equal to 1, so I get 1 minus 6, 1 plus 1. Here, if I put x is equal to 1, that whole term over there will disappear. So if I simplify, I get 10 is equal to b times negative 5 times 2. So 10 is equal to negative 10b. So b is equal to negative 1. Right. That's if x is equal to 1. And so I'll end up with negative 1 over x minus 1. Right. The next one, what substitution could work? Well, if I let x be equal to negative 1, then that'll disappear, okay, and that'll disappear. So my next appropriate substitution would be let x be equal to -1. So if I sub in there, I get 11 minus, trying to wake myself up here, 11 minus -1, x is equal to -1, poof, that's gone, x is equal to -1, poof, that's gone, and here you're going to get c, -1 minus 6, -1 minus 1, and so I get 12 is equal to c, and I'm going to end up with -7 and -2, so I get 12 is equal to 14c, so 12 over 14 is equal to c, which simplifies to 6 over 7. So therefore c is equal to 6 over 7. It's not wrong because it's a fraction. Fractions have the right to exist too. So I've got b is -1 and c is equal to 6 over 7. And then I'm going to actually go up here to do the last bit. Still going to sub into that though. And what's my final substitution that'll work? Well, I've used, what have I used? -1 and 1. And I can still use 6. 6 will get rid of that, and 6 will get rid of that. So if I left x is equal to 6, I'm going to get 11 minus 6 is equal to, this won't disappear, so you're going to get a 6 minus 1, 6 plus 1, blah, 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 and I get 5 is equal to a 5 times 7. So 5 is equal to 35a, so 5 over 35 is equal to a, so 1 over 7 is equal to a. Right, so I've got a is 1 over 7, so I've got all three of my variables from here. Okay, so your final answer, your solution is going to be 11 minus x over x cubed minus 6x squared minus x plus 6 is going to be equal to, right, a over x minus 6, a over x minus 6, but a is equal to, so you could write it like this, but it's very ugly. I'll show you how you make it better. So a is 1 over 7 divided by x minus 6 plus b, which is -1, so it's going to be plus -1 over x minus 1 plus c over x plus 1, and c is 6 over 7 divided by x plus 1. And to make that prettier, well, this means the same thing as 1 over 7 x minus 6 plus and a minus maker minus 1 over x minus 1, and this bit over here you can write as plus 6 over 7 x plus 1. And there is your final solution. If you've got time on your hands and you can't go out or don't want to go out, which is not true at the moment, okay, go add those together and you'll see you get back to that. Right. Please do the rest of that worksheet. Evans exercise 2.1. Do the other ones. The memo is up on Teams. Okay. Have fun and good luck out there, rat scum. Farewell. Bye.